Hi, it's Kiffin Low Bates here, and today's video is both a resonance security video, as you can see by the hat, and also a blockchain video, so that's unusual. And the reason for this is because I thought I would talk a bit about the recent Bybit hack. This is a hack in which criminals managed to subvert a digital wallet owned by the Bybit exchange and tricked one of the staff into signing a transaction that transferred $1.4 billion worth of digital assets such as Ether to an address controlled by the criminals. And the way that the hack apparently worked is that the criminals managed to subvert the user interface of the wallet so that the user thought they were signing a valid, acceptable transaction that was simply transferring assets from a cold wallet owned by the exchange to an address in a warm or hot wallet owned by the exchange. But the underlying transaction was actually to transfer the assets to an address controlled by the criminals. And I have in the past made a series of videos called Ledgers and Layers, where I talk about the difference between the data within the system, so what is truly going on under the hood, and the presentation layer, which is stuff that is shown to users in a human understandable manner. And one of the problems we have in computing is that you are relying on the interface truly reflecting what is going on at the data level. Now, this is not the OSI 7-layer model. When I talk about presentation layer and data layer, they are different things. I'm talking about the data being the transactions and the entries in the ledger that say who owns what assets and how they should be moved around, versus the presentation layer being something like MetaMask or a web wallet or some kind of visual representation for the user that is meant to explain to them what is going on so that they can make informed choices as to what they do or do not sign. And we had the same problem in the metaverse and blockchain-based games, which is that it's all very well to have an NFT, for example, that represents a magic sword in a game. The fact remains that the game itself is not running on a blockchain. It's just using the blockchain as a data store, and the game designers can decide to show your asset within the game in any way they like. So you may think you have bought a fine magic sword, you go into the game and it turns out there it's represented as a banana or nothing at all. And that's because the game is a presentation layer and the assets are stored in a data layer in the form of the blockchain. Now, in this particular case that I've just given, it's not a big problem. You're just going to be annoyed that you didn't get what you paid for. In the case of the Bybit hack, the fact that the data presented did not match the underlying activity that was going on ended up costing Bybit over $1 billion worth of digital assets. And yes, that figure is staggeringly high, over $1 billion of digital assets stolen. And one of the problems is that blockchain doesn't solve this. Blockchain is a data layer. It's not a presentation layer. And this reminds us that computer security is not just about making sure that you understand what's going on in a smart contract or that your transactions are properly formed and things like that. It's also making sure that the data to human interface is accurate and valid, and that means that your presentation layer needs to be properly secured. In Bybit's case, unfortunately, that wasn't done. And there are a number of ways that you can do this from a security perspective. One of them is to ensure that your interfaces are carefully controlled, that any changes made to them are checked, that you're running everything on a secured network, that you're doing things over VPN and stuff like that. Another one is to build belt and braces systems at the data layer, where you make sure that it's just simply not possible for bad transactions to be carried out. That requires a bit more thought, and it looks that in Bybit's case they didn't consider these kind of scenarios, and therefore they hadn't guarded against them. And really, that's the role of computer security professionals. It's to think of all these edge cases, all these weird things that malicious parties and hackers might try, and then guard against them. And of course, that leads to one of the fundamental problems of computer security, which is that as a defender, you have to defend against all possible attacks, whereas if you're an attacker, you only need one attack to succeed. So it's not an enviable job. It is fortunately a very interesting one, and if you're interested in finding out more about computer security and how to secure your systems against things such as the Bybit hack, why not get in touch with Resonance Security? That's at resonance.security on the web. I'll wrap this video up for now. Hopefully it's been clear enough in explaining what went wrong, and I'll put a link in the comments to that series on ledgers and layers, because I think although it's 6 videos and would take about half an hour to watch, it's half an hour very well spent, because it explains all the differences about these different layers, because there are actually more subtleties to it than I've just covered in this short video. I hope you found this interesting. I hope you've learned something, and I'll see you in the next video soon. Bye for now.